Alright, hi y'all. This is Unit 6, video number 2. This is all about straight line motion. So we're going to be imagining a particle is traveling along the x-axis or along the y-axis, and we'll be analyzing the position, the velocity, and the acceleration of this particle. Okay? So some notation, x of t traditionally is the position function. Right? So where are you along the x-axis at any given time t? If we take the derivative of that, that would give us our velocity. And the derivative of velocity is acceleration. Okay, typical units for this would be, let's say I measured the position of something away from its starting point in terms of feet. If we measured that against time, so feet per, let's say, second, that would be our velocity. And if we measured feet per second, so feet per second, and analyze that over time, or feet per second squared, that would represent our acceleration. Okay? This will be a really important topic throughout the year. As you move down this chart, we are taking the derivative. Right? Later on in the semester, or next semester, we will be moving up this chart, so we'll have to be taking the antiderivative. So really important to know position, velocity, and acceleration. Okay. So please read through these definitions and make sure you're very clear on them. Again, position is just where the particle is at a certain given time. Okay. Displacement is how far away from the starting point you are, and it's not equivalent to the total distance traveled, but we'll deal with that next semester. The velocity is how fast and in what direction the particle is going. Okay, and this is really what we'll be analyzing the most, is the positive velocity, negative velocity, and if the velocity is zero. Okay, so if the positive velocity means that the particle was either traveling to the right or up, depending on the orientation. Okay, if you have a negative velocity, that means the particle was traveling down or to the left or down. And if you have a zero velocity, that means that the particle was stopped, not moving. Okay. Let's see, speed is on the same level as velocity, but speed does not tell us the direction, it just tells us how fast. So think about that. If we want the numerical value, but we don't care about whether positive or negative, so traveling to the left or to the right, we'll just take the absolute value of velocity. So speed is related to velocity, and it will be the same numerical value, but we will not see the sign, the positive or negative. Okay. And then again, acceleration is just the rate of change of the velocity. So we will totally be using all this. Just one last thing is we'll be looking at whether a particle is speeding up or slowing down at a given certain instance. Okay. I know I naively first thought that that was just asking me about acceleration when I first started teaching calculus. But now, of course, I know better that it's not just about the acceleration. We actually need to compare both the velocity and the acceleration at a given time to know whether the particle was speeding up or slowing down. So you won't, this is kind of just like why the rules are the way they are, is we consider if we had a positive velocity, and by the way, all these sketches here are going to be of v of t. Okay, so I'm looking at a graph of v of t. When the velocity is, for this first case, positive, and the acceleration is positive. Right? Well, velocity being positive, and if we're staring at a graph of velocity, that would just mean physically above the x-axis. Okay? Acceleration being positive means the rate of change of velocity is positive. That means the function would be increasing. So increasing and above the x-axis, maybe something along those lines. Okay? Velocity positive while acceleration is negative means I'm above the x-axis, but now my function was decreasing. Velocity negative, acceleration positive means I was below the x-axis, but my function was increasing. So negative velocity, but acceleration positive. Okay. And then velocity negative, so below, and acceleration negative, so also function was decreasing. Okay. So if we look at those four situations and then graph the speed, knowing speed is the absolute value of velocity. Well, if speed is the absolute value of velocity, I just know that every single value is always going to be positive. So this guy's going to stay exactly the same. This guy's going to stay exactly the same. This guy, if you imagine flipping him, for every value that I was here, now I'm going to make that exact same value be positive. Right? I was here, now I'm going to make him positive. Basically, he would turn into that graph. And over here, if I turned all of these values positive, right, now he would turn into this kind of graph. Okay. So you can see that the function here, whether speeding up or slowing down, would literally be whether the speed was on its way up or whether the speed was on its way down. Okay. So if we can see here, the speed would have been increasing, speed would have been decreasing, decreasing, increasing. So if we look at all those patterns, we can summarize it in these two statements. the particle will be speeding up if the signs of the velocity and the acceleration agree, either both positive or both negative. The particle will be slowing down if the signs of the velocity and acceleration disagree. One's positive while the other one's negative. So you do not need to like graph these every time or anything. If you can just memorize that this is the way it'll work out, you can just find those two values every time. Okay? So speeding up, slowing down. Another way to ask this would be, was the speed increasing or decreasing? If they ask that, that's the same question as speeding up or slowing down. Okay. So let's go ahead and jump into our first example. We're going to work with a polynomial function, and this has been given as the position of an object or particle in feet, where t is in terms of seconds. So part A asks us to find the equation of the velocity and acceleration. So the velocity equation will just be the derivative of the position. So I'll pop that 3 out in front, and decrease by 1. Pop that 2 out in front, decrease by 1. 3 and 0. So final velocity would be t squared minus 4t plus 3. And same part A, acceleration, take the derivative of velocity. So acceleration 2t minus 4. Okay. Also asked us to indicate units of measure, right? So if we think about this, if our position was in feet and time was in seconds, velocity would have been in terms of feet per second. Right? Acceleration would be feet per second squared, or feet per second per second. Part B is asking, is x of t increasing or decreasing at time t equals 4? So we want to know if x of t, if we were to graph this, right, at t equals 4, was the graph going up or was the graph coming down? Remember, to figure out if something's increasing or decreasing, we can look at the derivative of that thing and check for the positive or negative sign. Positive or negative. So to figure out if x of t is increasing or decreasing, look at the derivative. So we already know the derivative, right? And see whether we get a positive or negative when we plug in 4. So plugging in 4 into v of t, right? 4 squared minus 4 times 4 plus 3. What does that give us? 16 minus 16 plus 3 gives us 3. So because the velocity at 4 was 3, therefore I know that x of t was increasing at t equals 4, and because it would really be because x prime of 4 was greater than 0, right? X prime of 4, which is the same thing as velocity. Part C, is the object speeding up or slowing down at time t equals 4? We need to explain. So object speeding up or slowing down, it is not enough just to look at the acceleration at 4. We also need to consider the velocity at 4, which we just found in part B. So the velocity at 4 was 3. Now if we can figure out the acceleration at 4, so 2 times 4 minus 4, 8 minus 4 would be 4. Okay. So because the acceleration is positive and the velocity was also positive, so therefore the particle was speeding up at t equals 4, because we would say that a of 4 was greater than 0 and v of 4 was also greater than 0. Okay. Last one on this problem is, when is the particle stopped? So when is the particle stopped is when the velocity equals 0. Okay, so we can find out when the velocity equals 0. So that was t squared minus 4t plus 3. When does that equal 0? Little bit of some algebra, some factoring. Looks like we get down to t minus 3 times t minus 1 would equal 0. Therefore, when t equals 1 and when t equals 3, the velocity or the particle would have been stopped. Okay. This next example is when you're given a graph and you can figure out the exact same information given a graph. Okay. So if you would please pause and pause poster. If you would please pause and read through the question on your own. So we have a squirrel, right? Building A, he's leaving at time t equals 0 and he's getting to building B. And this is the velocity equation of this squirrel. So again, we're staring at the velocity information, right? Okay, so letter A. At what times in the interval from 0 to 18, if any, does the squirrel change direction? Okay, give a reason for your answer. So the squirrel will change direction Think about that. The squirrel will be traveling to the right when the velocity is positive, to the left when the velocity is negative. Okay, and when the velocity is 0, that means the squirrel was stopped. Okay, so if we can look at this picture, because the velocity is positive, positive, positive until we get here, then the velocity turns negative until we get here, and then positive again. Right? I know that at this spot here and at this spot here, the squirrel changed direction because the velocity changed from being positive to negative or changed from being negative to positive. Okay? So for letter A, we would say the squirrel changed direction at, looks like it was t equals 9 and t equals 15. And that was what, in terms of, did they not give us units? I don't know if it was minutes or seconds or something along those lines. And this would be because V, right, changes from positive to negative or negative to positive there. At either of those values. Okay. So notice here, it would not have worked if the graph had just touched the x-axis and then gone back up, or vice versa, touched the x-axis and come back down. The squirrel would not have changed direction. The squirrel would have stopped, but then kept going in the same direction. Okay. So keep that in mind. Letter B, write expressions for the squirrel's acceleration and velocity from 7 to 10. So from 7 to 10, we want to come up with an equation of the squirrel's velocity and acceleration. So velocity, right, from 7 to 10, we're basically looking at this linear equation here, and we're given 2 points that it goes through, so it looks like we're going through 7, 20 and 10, negative 10. So essentially I need to figure out the equation of that line, right, and that would provide our velocity for that. So to find the equation through this line, I'm going to need to find the slope, right, so the slope would be negative 10 minus 20 over 10 minus 7. What would that give us? Negative 30 over 3, so negative 10. Hopefully that's reasonable, right, looking at the picture, that our slope of this line could be negative 10. Okay. And then to figure out, right, if we actually graphed this whole line out, right, we would be crossing through up there at B. So I'm just going to write the equation of this line going through either this point or this point. And I like point slope form, so y minus y sub 1 would equal m, which I just figured out was negative 10, times x minus x sub 1. Might be easiest, I mean we could use either of those 2 points, but we did know that it was crossing through, I guess we assumed, that it was crossing through at 9. So let's go ahead and use that point as well, which would make sense, right, because we're going down 10 to the right one. So down 10 to the right one, down 10 to the right one, yes, so 9, 0 would be good. So 9 is here, 0 is here. So we're looking at what? Y equaling negative 10x plus 90, right? In terms of just like a linear equation. Now if we think about what the velocity would be, right? So the velocity is in terms of time, so we'd want to change that variable to t, right? So it'd be negative 10t plus 90. And again, that was good only from, what, 7 to 10? Last question here was the acceleration from 7 to 10. And that's the nice thing, right? We already found the acceleration. The acceleration is the rate of change of velocity. So essentially that was just the slope of that linear equation, which was negative 10. And let's not forget our units, right? This, oh wait, no, I don't think I put units on this one. So no units were necessary. All right, y'all, I actually have a special guest lecture for the last problem, if you would hang in there and check out this guy.
Jakey is coughing once every 5 seconds. How many times will he cough in 6 hours? Try to find the answer. And the answer is, you're about to see right there, 4